class, and welcome to lesson 7.1 on equations. So we just did our last chapter working on expressions, and now we're working on equations. Who remembers what the difference between expressions and equations are? Olin, what's the difference?
The difference between equations and
Expressions
is equations, you actually solve them.
Yeah.
Expressions, you just write the problem.
Exactly. Equations we actually solve. They will have an equal sign. Expressions, unless they tell us what our variable is, we're just left with a variable. So an expression would be something like 2 times a, 2a. An equation would be something like 2a equals 6. So we see the difference is simply having an equal sign. I want you guys to solve these 4 problems. On your fingers, show me what the answer for the first one is. Yes, everybody, we get x equals 3. For this second one here, on your fingers, show me the answer. Yes, we get x equals 4. On this third one here, show me the answer on your fingers. Yes, x equals 3. Camilla, what is the answer for the last one?
The answer for the last one is 16.
16. What we're seeing that's happening here is this is x divided by 2. Remember, that's how we can write it. That means x divided by 2. But here's the important part. You guys need to know the proof. Of course, we were able to do most of those in our head. I mean, right? We took kindergarten math. But let's see how we can do it with a proof. I want to get x by itself. Notice I want to end up with x equals. What is on this side with x over here? What number's on the side with x, Brian, in the one I circled? Perfect. 2 is on the same side as x. So because 2 is on the same side as x, we want to get rid of it. If I have $2, how can I get rid of my $2? If I have $2, how can I get rid of it? Vahe, how would I get rid of my $2?
By spending it.
By spending it. So I'm going to take away $2. Hey, you guys, though, think about what my chant is. What we do to one side, we do to the other. So there's an equal sign, and I'm going to take away 2 there as well. Isn't this the same? Isn't negative 2 equal to negative 2? It's the same on both sides, right? We can all agree on that. So 2 minus 2, that goes away. And now I'm just left with x. And 5 minus 2 gives us 3, which is exactly how you guys ended up getting that answer. Let's look at this one over here. I have 7x equals 21. So that means 7 times x equals 21. Again, I want to get rid of that. I want to just end up with an x. So how am I going to get rid of multiplication? What is the opposite of multiplication, Lucas?
I would say like division.
He would say division. He is correct. The opposite of multiplication is division.
Didn't you also want to say that multiplication and division are the same?
Kayla, what is 7 over 7 equal to?
So what you do is you would divide 7 and 7, okay?
Yep, we divide 7 and 7, and what do we get? 1. Anything over itself is equal to 1. So those cancel out. The biggest mistake people make is they think it's equal to 0. But something over itself is always equal to 1. So now I'm left with 1x. What I did to one side, I do to my other. On your fingers, you guys, because you all got it right in the chat. What is 21 divided into 7 groups on your fingers? What is it equal to? Exactly. It is equal to the 3 that we got. Hey, if I had a multiplication problem and I solved it, I got my variable by using division, then how do you guys think I'm going to solve this division problem? What do you guys think we're going to do? How am I going to get x by itself, Amelia? Yes. We're going to use multiplication. And she got 2. How'd you get 2, Amelia?
Because 2 is the, I want to say denominator.
Yeah.
Okay, yeah, the denominator of the fraction.
Mm-hmm. And I want to multiply both sides by 2, because what we do to one side, we do to the other. Here, 2 over 2. That's the same thing as 2 over 2. And just like Kayla told us before, anything over itself is equal to what, you guys? Show me on your fingers. Anything over itself is equal to? Yes, I see it on a lot of your fingers. Yes, it's equal to 1. So that goes away. And then 8 times 2 gives me 16. So we solve these problems by doing the opposite of what's happening. So for example, like I said, just like I showed, I want to get that x by itself. This 2 is on the side. It's a positive 2. I'm going to take away 2. What you do to one side, you do to the other. We get rid of it. I am just left with x, and 5 minus 2 is 3. This one's a little harder, but we worked on writing expressions in our last chapter. So I want you to write the equation. This time it is going to have an equal sign. The total cost of a pair of skates and knee pads is $63. The skates cost $45. How much are the knee pads? So the first question that I want to ask you guys is, what is the piece of information we don't know? What is the one piece of information I don't know? Jessica. So it's how much are the knee pads? Yeah, perfect. We don't know. It says how much, so we don't know. Marley, how did you write your equation? Excellent. She put 45 plus x equals 63. Just like what we said, is means equal. So it says the cost of a pair of skates and knee pads, and means plus as we know, is $63. Is $63. The skates cost $45. So this was the skates plus the knee pads. Just like what we did in the earlier problem, Lucia, how am I going to get x by itself? We subtract it. What are we subtracting? So exactly, as Lucia said, to get rid of addition, we're going to subtract. So I'm going to want just this x by itself. I want x equals something. I want x equals something. So to get x by itself, there's this troublesome 45 in the way. I'm going to take away 45. But what we do to one side, as I'm writing it all silly like, we do to the other. And as all of you guys wrote in the chat, what did we get our answer to be, Ben? 18. Yes, great job everyone in the chat. Great job. So we find out the knee pads cost $18. How does anyone think we could check our work? What could we do to check our work? Vahe, what do you think we could do?
Actually, we already did it, so...
Well, we did it, we solved it, but how do we think we could check our work? Ooh, Kayla, yes?
You can do 63 minus 45.
And that's how we did get the 18, but how do I go back and check my work? Make sure that 18 is the correct answer. Camilla, yes?
You add 45 and 18.
Yeah, we add 45 and 18. I see Lucas is super excited over there. Remember, it's just like our plug and play math. Remember when they tell you, oh, m equals 2, c equals 1/2. Just like what we saw, we test it by plugging it back in. And when we plug it back in, we indeed get 63. I want you to try this one. The difference between an ostrich's speed and a chicken's speed is 31 miles an hour. An ostrich can run at a speed of 40 miles per hour. What is the unknown information here? Who'd like to tell me what our unknown piece of information is? So exactly as Abner said, we don't know what the chicken's speed is. And what does that keyword difference mean? What does the keyword difference mean? Vahe, yes? I see what you're doing, yes. I see what Lucas is doing. I love it, you guys. I love the mimes. Yes, Ava's doing it too. It means subtraction. I love the mimes, you guys. I love seeing all of you guys doing that. Exactly, it means subtraction. So the difference between an ostrich's speed. So an ostrich, difference, chicken, means equals 31. Awesome. But now I want to plug in what I do know. Delaney, what do I know here?
You know that the chicken speed is 31 miles per hour?
Ooh, we know it's 31 miles per hour less than something. Lucas?
Well, I mean, it said, so I think like with the ostrich, it says 40. So it'd be like, under the ostrich, it would be 40, and then minus, like, X equals 31.
He's perfectly correct. He is absolutely correct right there. He is absolutely correct. So write in the chat what the answer is. So Eduardo, what do we get as our answer?
9.
We get
40
Yeah, we get 9. 40 minus 9 equals 31. We just use our big brains. We just know that. And thank you guys. You did it so well in the chat. You guys were excellent. So I want you to go to the guided practice, page 516. The guided practice, page 516. Here's what I want from you guys. I would like you guys to show your work. The ones that are easiest to show your work, this one is going to be hard. Number 2 is going to be hard. We're going to discuss how to do that one later. And then the others are easy to show your work. Remember, how do I solve a problem? I do what to get X by itself? I do the what of what we see. So Ruby, for the first one, how am I going to solve? What am I going to do?
Well, I'm not really sure like how to do it, but for W, I know that it's 8.
For W, you know that it's 8. How do we get that 8? Remember, we're going to do the opposite. So what's happening? We've got 9 plus W.
Subtract 9 from 17.
Yes, exactly. We want to get rid of that 9 on this side. So I'm going to subtract 9 from each side. Be careful. The biggest mistake people make is they try to subtract 9 from W as well. We can't do that. We don't know what W is yet. One side equals the other. What we do to one side, we do to the other. Here, I am just left with W equals, and as she said, and as most of you put in the chat, 8. Excellent. Let's see. I want to try with this one. Hannah, let's work through this one together. So using our knowledge of the identity property, Hannah, 8 divided by what is equal to 8? What do we think, Hannah? Perfect, Hannah. Our answer is 1. 8 divided by 1 is 8. Our identity property. Our identity stays the same. Excellent. Sebastian, can we try number 3 together? So, excellent. Let's see. It says X minus 11 is equal to 23. I want to just get an X equals. What's on the side of my X equals that's throwing me off? What's the number there? What is the...
Minus
Yeah, minus what?
11.
Perfect. We see negative 11, minus 11. How am I going to get rid of negative 11? If you owe some money, we want to get back to 0. How are you going to get rid of negative 11? We're going to... Excellent. We're going to add. So I just add 11 on that one side, right, Sebastian? Exactly. 11 plus 23 as well. What we do to one side, we do to the other. And Sebastian, what is 11 plus 23?
34.
Yes, 34. And if we checked it mentally, if we went back and checked it, we would see we would get the answer. Delaney, what about this one? This is 4 times x equals 32. 4x equals 32. How am I going to solve it?
I put 4 times 32 because 34 is a factor of 32.
Ooh, she put 4 times 32 because 4 is a factor of 32.
Oh, 4 times 4.
Ooh, she said 4 times 4 because it's a factor. What do we think? What do we want to add to that? Amelia, what do you want to add? What do you think that she is possibly doing a little wrong?
Number 4?
Yes.
What she's doing wrong is she is not, sorry, you just stressed. You're not dividing.
Ah, she needs to divide. Delaney, why do you think Amelia told you need to divide?
1 second.
Yes. Why do I have to divide instead of multiply? Because what's happening right here?
There's 4x.
Yeah. And when they touch, that means they are?
Multiply.
Yeah, exactly. When they touch, it means they're multiplying. So I want to do the opposite. I want to get that x by itself. What we do to one side, we do to the other. And everyone on your fingers, what is 4 over 4 equal to? What is 4 over 4 equal to? Yes, everyone, yes. It is equal to 1. So that goes away. We could just write 1x, but we don't want to write 1x. We just write x. And then, Delaney, what is 32 divided by 4?
It's 4.
Perfect. It's 8. So just make sure we practice our multiplication and our division. So great job those who wrote it in the chat as well. Let's see, Romina, let's try to work on this problem. Mississippi and Georgia have a total of 21 electoral votes. Mississippi has 6 electoral votes. So I want you to write the thing down to solve this equation. So we see this equation right now. Why is this the equation first, Romina? How did they get that equation? How did they get 6 plus g equals 21?
They got 6 plus g equals 21 because, so Mississippi has 6 electoral votes, and Mississippi and Georgia together have a total of 21 electoral votes.
And do we know Georgia's amount of votes?
No.
Exactly. Perfect. Look at that. So, Romina, how am I going to solve that using my showing my work? I have 6 plus g equals 21. What am I going to do?
Find out what number g is.
Yeah, so how do I do that? I want to get rid of that 6. How do I get rid of that 6?
Cross it out and pretend it's not there.
I wish you could do that. Yes, but how do we cross it out? I have to do what to it? What's the opposite? It's currently like a positive 6. What do I do to get rid of it? If I have $6, how do I get rid of having $6?
You spend it.
I spend it. Minus 6 on both sides. I know it's a little hard to see here. Minus 6 on both sides. 6 minus 6, boom, gone. I'm left with g equals, and Romina, what is 21 minus 6?
15.
Perfect. And then we would plug it back in to check our work. The last one. Riley and her sister collect stickers. Riley has 220 stickers in her collection. Her sister has 55 stickers in her collection. Riley has how many times as many stickers as her sister? So Pearson, can you explain to me why our equation is 55x equals 220?
It's because
So exactly, 55x, they're touching. That means it's multiplying. The question that it's asking us is, how many times as many stickers? So we're timesing, we're multiplying, but we don't know how many. We know that her sister has 55 and Riley has 220. So then, Pearson, how am I going to go about solving this problem?
So this is what I did. I did 220 minus 55. That
Ooh.
equals 2.
You're almost there because wait, Pearson, you just said it was multiply. How do I do the opposite of multiply?
Divide. Right. So,
So we divide both sides, right? So we always have to do the opposite. We divide both sides.
20, we get 160.
Marjorie, what do you get as the answer?
So I got 4.
She got 4. Excellent. Yeah, she gets 4. And we could check our work again because for X we got 4. Our problem was 55X equals 220. So I have 55 times 4. Can I just do 554? Is that how I just plug in with my X? Do I just put the X there? Lucas?
No, but something I just noticed is that if you take away one of the 5s on 55, it's 20.
Oh.
5 times 4 is 20, and 55 times 4 is 220.
Yes, you used your big mental math there. And we find 55 times 4. Lucas split it up. He split it into 50 times 4 and 5 times 4. He knew that that was equal to 20, and he knew that was equal to 200. So he found it's 220. Or we can just do our up and down multiplication, which is the same exact way. 4 times 5 is 0. We carry the 2. 4 times 5 again is 20. We have that too, so we get 220 as our answer. So that's all we need to do. We do the opposite of what's happening on the same side as X. So your homework tonight is page 517, numbers 1 through 13. I want you to show your work on as many problems as you can. There might be some that would be hard to show your work, but I want you guys to show your work on as many problems as you can.